Maths Chapter 1. Relation. A relation R from set X to a set Y is defined as a subset of the Cartesian product X times Y. We can also write it as R, X, Y, X times Y, X Y. Note: if n equals P and nb equals Q from set A to set B, then n times B equals PQ and number of relations equals 2PQ. Types of relation. Empty relation. A relation R in a set X is called an empty relation if no element of X is related to any element of X. Universal relation. A relation R in a set X is called universal relation if each element of X is related to every element of X, i.e. R equals X times X. Reflexive relation. A relation R defined on a set A is said to be reflexive if X, X, R, XA or XRX. XR symmetric relation. A relation R defined on a set A is said to be symmetric if X, Y, R, Y, X, R, X, Y, A or X, Y, R, X, X, Y. R transitive relation. A relation R defined on a set A is said to be transitive if X, Y, R and Y, Z, R, X, Z, R, X, Y, Z, A or X, Y, Y, R, Z, X, R, Z, X, Y. ZR. Equivalence relation. A relation R defined on a set A is said to be an equivalence relation if R is reflexive, symmetric and transitive. Equivalence classes. Given an arbitrary equivalence relation R in an arbitrary set X, R divides X into mutually disjoint subsets A, called partitions or subdivisions of X satisfying all elements of I are related to each other. For all I, no element of I is related to any element of AJ. I does not equal J. I AJ equals X and I AJ equals 0. I does not equal J. The subsets I and AJ are called equivalence classes. Function. Let X and Y be two non-empty sets. A function or mapping f from X into Y written as f, x, y is a rule by which each element XX is associated to a unique element Y. Y then, f is said to be a function from X to Y. The elements of X are called the domain of f and the elements of Y are called the codomains of f. The image of the element of X is called the range of X, which is a subset of Y. Note: every function is a relation but every relation is not a function.